This video contains instructions if you are skipping the Insert Cursor section, which I highly recommend you don't, or if you're coming back to this course at a later date. We have the data nicely set up for you to jump in at this point and not have to redo the workflows from the Insert Cursor section. From your C drive, click into the ArcPy Cursors folder. Then we go into our APRX and open up our ArcPy Cursors APRX. Currently, we are showing our original datasets. Over on the right hand side, in Databases, click to expand and expand our ArcPy Cursors GDB. Select all the feature classes, right click and select Delete. And say yes, we want to permanently delete these items. We will see them disappear from our map. We go back over to the right hand side. In our databases, we have the UpdateCursor Start Geodatabase. It is also in our folders, ArcPy Cursors and Original Data. Expand the UpdateCursors Start GDB. Select all the feature classes and right click. Select Copy. And we go back up to our databases and into our ArcPy Cursors GDB. Right click on the GDB and select Paste. Once the feature classes are in the geodatabase, we go down to our symbology folder and expand. We select all our layer files and drag into the map. We bring the Celbridge buildings above the other Celbridge buildings layer, and we are ready to go with our Update Cursor section. Welcome to the section for our third and final cursor, the Update Cursor. The Update Cursor is an ArcPy Python object that facilitates the modification of existing rows in a table. The Update Cursor provides read, write and sequential access to iteratively update attribute and geometry values. The Update Cursor is very valuable for automating data management tasks by enabling you to make changes to attribute values and geometries within a dataset programmatically. Here we have a dataset that has an object ID field and 3 fields including the geometry. When we use an Update Cursor object, we can iteratively update each record in our dataset. If an order by has not been stated in the SQL clause, the sequential iteration will be done based on the object ID. In this example, we have used every row in our dataset. But we can also select a subset of rows to update based on using an SQL statement with the where clause parameter. Not only that, but we can define certain criteria where only certain fields get updated with our cursor. Update Cursor knowledge and experience will enable you to perform efficient data management tasks on your datasets by only updating and manipulating the required and targeted data. The Update Cursor also has the capability to delete rows from a dataset. Deleting a subset of rows can be very beneficial for data management practices. In this video, we delivered a brief overview of the Update Cursor. In the next video, we will go through the Esri documentation for the Update Cursor to gain more foundational knowledge before we walk through practical and technical examples of using the Update Cursor. By the end of this section, you will be fully armed with mastering the use of the ArcPy Update Cursor for your own workflows. In this video, we will walk through and talk through the Esri documentation for the Update Cursor. Here we have the documentation for the Update Cursor as of ArcGIS Pro 3.2. We can also access other versions from the 3 series, 3.0, 3.1, and we can also go back into the 2 series by going to the URL, and where it says latest, we could go to 2.9 for example. And we see here that there is a warning that the ArcGIS 2.9 documentation has been archived and is no longer updated. But you can find all the information for that version of ArcGIS Pro and the Update Cursor. We'll go back to the latest version, which is 3.2, and we'll go through the documentation. The Update Cursor allows the user to have read-write access to records returned from a feature class or table. It's important to note that the Update Cursor returns an iterator of lists. The order of values or attributes and geometry returned by the cursor matches the order of fields specified by the field names parameter. And we'll see this time and time again in our examples. We can iterate through the update cursor using a for loop. We will also be using the Python with statement to reset iteration and aid in the removal of locks. We will also see the delete keyword in Python in action to delete a cursor object out of memory. We have a note here that using an update cursor on a layer with a joined table is not supported. In other words, we cannot use an update cursor on a temporary join. Let's take a look at the syntax for the update cursor. The syntax is actually ArcPy.da.updateCursor. It would be nice to see Esri update the documentation to reflect this. There are two required parameters, the in table and the field names. There are several optional parameters that I'll list right now. That is the where clause to help subset data returned by the cursor, spatial reference, which is often used in tandem with the datum transformation, explode to points, SQL clause, explicit, spatial filter, which is new as of ArcGIS Pro 3.2, and when set you can add the optional spatial relationship. And lastly we have search order, which is only available in enterprise geodatabases. So let's talk through each parameter. The in table is the feature class layer table or table view that we wish to update attributes or geometry for. In our examples we are going to focus on feature class or layer. The field names is a list or tuple of field names as strings. For a single field we can also use a string instead of a list of strings. If you want to access all fields we can use the asterisk as a string rather than supplying all field names as a list of strings. Esri do recommend, however, that for faster performance and reliable field order, that the list of fields be narrowed to only those that are actually needed. In our examples, we will use the asterisk and a subset of fields supplied as a list. We can also use tokens to update additional information. We will see that we can use the shape at tokens, such as the shape at XY, to update a point geometry. We also have an example where we just update the X value, the X coordinate for a geometry. And we'll also be using the shape at token, which allows us to use a geometry object to update the geometry for a feature. And some of these are read-only. The shape at area is a system maintained field, as is shape at length, but you can return these as read-only values. One of the more important tokens is the OID at token. This will return the value of the object ID field, but it is important to note that the object ID field is not always called object ID. It could be FID, it could be OID, or it could be another name. Using the OID at token allows us to access the object ID field no matter what it is named. We move on to the optional parameters now. First up is the where clause, and the where clause is an SQL expression that limits the records returned. So it allows you to update a subset of records from the dataset. You might have a rare instance where the spatial reference is required. You might have a geometry object from a different spatial reference that you wish to apply to a feature that does not have the same spatial reference as that geometry object. And if the two spatial references do not share the same datum, you will have to apply a datum transformation. The optional explode to points parameter will return a row for every vertex in the geometry. Every row will contain the attributes from the original feature, but the geometry returned will be a point geometry. We are going to see that we can actually update each individual vertex by using the explode to points parameter. The SQL clause with the update cursor is a bit of a no-go parameter. According to the documentation, the SQL clause is a pair of SQL prefix and postfix clauses organized in a list or tuple. The SQL prefix clause can be none, distinct, or top. Top is only available with enterprise geodatabases, and distinct will return unique values. We are going to see that distinct does not actually work for an update cursor. The postfix clause can support none, order by, and group by. If you know SQL, you are probably thinking, how could you ever update by group by using ArcPy? And the answer is you simply can't. We can of course use the order by if you want to specifically update things in a certain order, which I see very little value in. But the order by might be used if you want to return values in a certain order for reporting purposes perhaps. The examples here look like they've been copied and pasted from the SearchCursor, with little or no thought gone into the UpdateCursor documentation. The explicit parameter is quite a neat little option. It allows us to override a default value and supply in null instead if the field is nullable. We can see here if a field has a default value and the field is nullable, using the value of true will explicitly override the default value and insert null values into the record instead. When using a value of false, the default value will be inserted instead of null, and this is the default action. We can set explicit to true, meaning that explicit is set for every field that we have added to our field names parameter. But the explicit rule can also be applied to individual fields using a list of Boolean values. It is important to note that the list of values, so the list of Boolean values in the explicit parameter, must be the same length as the list of fields supplied in the field names parameter. We see an example below where we have 3 fields supplied as our field name parameter, and with explicit we have a list of booleans that also has 3 entries. So explicit is being set for the first 2 fields and not for the third. So for field 1 and field 2 and not for field 3. The optional spatial filter parameter is new as of ArcGIS Pro 3.2. The most important thing to note here is that this parameter must be a geometry object. You can use a geometry object to spatially filter features. When using this optional parameter, we can also set the spatial relationship value. By default, the spatial relationship value is intersects, but you have several other options such as envelope intersects, touches, overlaps, and contains for examples, and these just seem to be your typical spatial relationship operations. Lastly is the search order, and this is only available in an enterprise geodatabase. Like the SearchCursor and the InsertCursor, the UpdateCursor has one property, and that is called fields. It is a read-only property. This property is a tuple of field names used by the cursor. The fields tuple will include all fields and tokens specified by the field names parameter. Not only that, but the order of the field names from the field property will be the exact same order of the field names passed in with the field names parameter. We'll scroll down to the methods. We have deleteRow, which will delete the current row of the cursor. We have reset, which will reset the cursor back to the first row that was returned from the cursor. And of course, we have the updateRow method that allows us to update the current row in the table. We're going to see all 3 of these in action in our examples in this section. The updateRow takes one parameter called row, and this is a list or tuple of values that we wish to update. The order of values must be, not should be, must be in the same order as the fields supplied into the field names parameter. If you get the order wrong, you could be placing incorrect data into incorrect fields. We have a lot of examples to get through in this section, and by the end of this section we will have mastered the update cursor. In this video, we walked through the documentation for the update cursor. In the following videos, we are really going to get to grips with what the update cursor can offer. In this video, we will use the update cursor with required parameters only to update field attributes in a feature class. We are in the ArcPy Cursor's APRX. If we go up the top to the Analysis tab, and on the left where it says Python, click the drop down and open the Python window. We also want to right click on the Selbridge Buildings layer and open the attribute table. Let's dive straight in and use the update cursor. With ArcPy.va.updateCursor, supply in our Selbridge Buildings layer, and we're going to use the asterisk to return all fields. Finish off the statement as cursor, colon, and hit enter. Let's simply print our cursor to screen. And we see we have an update cursor object. Let's go again. This time we will iterate through our cursor for row in cursor. And we want to set every attribute in our recommend field to null. So our recommend is 0, 1, 2, 3, 4, 5. It is index number 5 in our fields. So we want to set row 5 to equal none. And we'll run. It ran fine. If we refresh the table, we can see nothing happened, nothing changed. The update cursor was not applied. This is because we need to call the updateRow method on the cursor. So let's go again. We'll add in our cursor.updateRow, and we need to supply in the row that has been updated. Before running this, there's something I need to show you, and you need to pay attention to this. I'll give our Selbridge Buildings attribute table a bit more real estate, and we'll scroll down. You can see here we have a handful of features that have a rating of null. We inserted these in the last section using the InsertCursor, where we applied the explicit parameter to allow us to add a null value rather than the default 0 value. You can also see we have entries for recommend, and these are going to be overwritten with null values. I'll scroll back down and let's run the code. And we will refresh our table. We can see that the recommend values have been set to null. And if we scroll down, it is null right the way down through all the attributes. But look at our ratings. Those that were set to null have now been set to the default of 0. You won't find this in the documentation. You have to see it for your own eyes. That is exactly what has just happened. Let's update some of those recommendations. We'll bring back up our update cursor. This time we are only interested in 2 fields. We will put in rating and recommend. We'll once again use for row and cursor, but we'll just delete what's below that for now. We'll go up to our Selbridge Buildings and right click and go to Data Design and go to Domains. We see here we have one coded domain, and this domain is applied to our recommend field. 1 is yes, 2 is no, 3 is depends on the friend, and 4 is to be decided. We'll go back into the Selbridge Buildings attribute table, and in our cursor we will use an if statement. If row 0, which is the rating, if that is greater than or equal to 4, we are going to update our recommend field, which is row 1, to equal 1, which is yes, we will recommend it. Else if our rating is in 1 or 2, so if our rating is 1 or 2, we are going to set our recommend to be 2, which is no. Otherwise, we use else, and we'll set our recommend to equal 4, which is to be decided. We then need to call our cursor dot update row method and supply in our row. And this row is coming from the for loop for row and cursor. So for each row, we are updating the row. Let's run our code. Actually, let's not, because I have an error there. Cursor should be cursor. Now we'll run. I'm going to refresh this table and we should see these nulls change to what we applied in the update cursor. And there we have it. None of them are null. They're either yes, no, or to be decided. In this video, we saw the update cursor in action, where we only use the required parameters. We saw that we need to call the update row method for the cursor and supply in the row in order for the row to update. We also saw a little quirk with ArcGIS Pro that when we ran the update cursor on a field that has a default value set and there are currently null values for that field, the null values got updated to the default value. In this video, we will use the optional where clause with the update cursor. The where clause is an SQL expression that limits the records returned by the cursor. We are in our ArcPy cursor's APRX. While it is not essential that you followed along the tasks of the previous video, just note that your rating and recommend values will be different than this video. We are going to use the optional where clause with the update cursor to specifically select the Abbey Lodge and update the rating and the recommendation. We currently have our Python window open and our Selbridge buildings attribute table. I'm going to clear the selection and head down to our Python window. We begin with ArcPy.da.updateCursor, and we supply in our Selbridge buildings, and we are interested in our rating and recommend fields. For our where clause, we want to set where name is equal to, I'm just going to copy the Abbey Lodge and paste in, and we wrap that in single quotes. And we'll finish off our statement with as cursor, colon, and hit enter. We then use our for loop for row in cursor. We expect there to only be one row. We want to set row 0, which is our rating, to equal 3. If I right click on Selbridge buildings and go to data design and domains, we're going to update the recommend to number 3, which is depends on the friend. So let's enter row 1, which is our recommend field, and we'll set that to equal 3. We then need to call the cursor dot update row method and supply in our row. We'll go back into our Selbridge buildings. We can see that the Abbey Lodge currently has a rating of 4 and a recommend of yes, which is a code of 2. So we're going to change both of these to 3, a rating of 3 and recommend to depends on the friend. We'll run our code, and if we refresh the table, we can see that that has taken effect. We'll clear the selection. This time we'll use name in, and we'll wrap in parentheses, and we will use sample sensations. We'll copy and overwrite the Abbey Lodge. I'll put a comma, some single quotes, and we'll also pick Gemini Hair Studio. So we'll copy and paste in. We're also going to add in the name field to the fields that we want returned. So our statement is now with ArcPy.da.updateCursor. We have our Selbridge buildings as our in table. Our fields are name, rating, and recommend, and our where clause is name, in, sample sensations, and Gemini Hair Studio. So we expect 2 records to be returned with this update cursor. Let's remove below our for loop. Let's do something different this time. Let's say for count row in enumerate, and we'll wrap the cursor in the enumerate, and we'll start the enumerate count at 1. Put a colon after our statement and hit enter. Let's print the count to screen. Then we'll enter an if statement. So if row 0, which is our name, equals, let's say, sample sensations, then we want to set row 1 to equal 1. That is our rating. And row 2 to equal 2. We are not recommending. We'll do an else if row 0 equals Gemini Hair Studio. Then we want to set the rating to equal 3, and we'll set the recommendation to be decided. So we'll set that to equal 4. We then step back out and call our cursor.updateRow function and supply in our row. Let's run our code. And you can see we printed out 1 and 2, which was our count. So for each row, we printed out an incremental integer. And there's only 2 in this instance. If I select Gemini Hair Studio and sample sensations, we can see the rating and the recommend. And if we refresh, we should see these update. Perfect. I'll clear the selection. In this video, we used the optional where clause with the update cursor to limit the records returned by the cursor. We saw that we could update a subset of features by using the where clause. In this video, we are going to use field tokens to access system maintained fields in ArcGIS Pro. We will see how we can use tokens to access and update geometry for features. We are in our ArcPy Cursor's APRX. While you don't have to have followed the previous videos in this section to follow along with this tutorial, just note that the rating and the recommend attributes for the Celebrate Buildings layer will be different than yours. We have our Python window open along with the Celebrate Buildings attribute table and the domains for our ArcPy Cursor's GDB. And you can open this domains by right clicking on Celebrate Buildings and going to Data Design and selecting Domains. I'll leave open the Celebrate Buildings attribute table. In our first example, we are going to use the OID at token. The OID at token accesses the value of the object ID for a field. It is a special token because object ID is not always the name of the object ID field. It could be FID or OID or another name. Let's start building our update cursor with ArcPy.da.updateCursor. We supply in our Celebrate Buildings, and we are interested in 2 fields, our OID at field to access our object ID and our recommend field. And we'll finish off code with as cursor with a colon and hit enter. So this cursor is going to return every record in our data set. There are currently 34. We'll iterate through those records with a for loop for row in cursor. And we're going to put in an if statement. If row 0, which is our object ID, and let's choose what we're going to do here. Let's scroll down to the bottom of our attribute table. Let's take the last 3 there. So we have object ID of 32. If row 0 is greater than or equal to 32, so if our object ID is greater or equal to 32, let's update the recommendation, so row 1 to equal 3. And if we go back into our domains, 3 is depends on the friend. We'll go back to the attribute table and we'll finish off our update cursor. Oh, I can see I have row instead of row. Now we'll finish off our update cursor with a cursor.updateRow and supply in the row. So the cursor.updateRow is only going to be called where the object ID is greater than or equal to 32. Let's run the code. We'll highlight 32 to 34 because that's what's greater or equal to 32, and we will refresh the table. And we can see our recommend has been updated to depends on the friend. We'll clear that selection. In our next example, we will update the building footprint, the polygon, for a feature. Let's create a variable called coords, and we'll set this to equal a list. This is going to be a list of lists containing point coordinates. I'm not going to type all these in. In the resources section of this video, there's a text file with all the code used. Please download. I'm going to copy and paste in the coords now. I'll overwrite the empty list and paste and hit enter. It's quite strange how you actually build a polygon with ArcPy. We first have to create a list of point objects. So let's create poly underscore points, set this to equal a list. We will use list comprehension. So for x, y in coords. So for each x and y in our coords list, we want to create an ArcPy.point object and supply in our x and y values. Let's run that line of code and we'll print our poly points to screen, and we can see we have 4 point objects with our coordinates as the x and y for each point. Now we create our polygon. We'll set this as geom and we'll set it to equal an ArcPy.polygon object. The inputs for the polygon object needs to be an array object. So we'll call ArcPy.array and we will supply in our polygon points, which is the list of point objects. You can check all this out in the documentation, which there's also a link to in the text file in the resources of this video. We'll run this line of code and we'll print geom to screen, and we can see we have a polygon object. Okay, let's jump into our update cursor. With ArcPy.da.updateCursor, select our Savage buildings. We're going to use the OID app token as we did in the previous example. We need this to be a list, and we also add in the shape app token that allows us to access the geometry for a feature. We finish off with as cursor and our colon and hit enter. And then our for loop for row in cursor. We'll say if row 0, which is our OID, our object ID, equals, and let's pick one. Let's pick the duck. And let's take a look at that on the map. We can see this highlighted building here is the building we have selected, the duck. And that has an object ID of 25. So we add that to our code, colon and enter, and we'll set row 1 to equal our geom. So we're setting the shape at token to equal our geom variable, which is our polygon object. We then call the cursor.updateRow method and we supply in our row. So the update row will only be called if the object ID is equal to 25. Let's run our code. Okay, the moment of truth. Here's our old building footprint and we are going to refresh the map. Oh, it's gone. Where did it go to? Sorry, I probably should have zoomed out a bit there more before refreshing, but we can see the building is now being moved and the old one has disappeared. I'm going to clear the selection for our Savage buildings and we will open the attribute table for our Savage points of interest. Back in the InsertCursor section, we inserted a new feature for Castletown gates, which was this point here. But someone has come along and moaned that the point isn't exactly in the right place and they wanted more at this intersection here. So let's give them what they want. Let's set x to equal 697.416.27. The y looks good enough. We'll hit enter. We'll use our update cursor with ArcPy.da.updateCursor. This time we select our established points of interest. We create a list for our fields. We're going to use two tokens again. We're going to use OID at, and we will use the shape at X token. We are only going to update the X value for our feature. Finish off with as cursor, and we'll jump into the for loop for row in cursor. Actually, do you know what? I've changed my mind. This time we are going to use a where clause, just to be different. So we'll say where the object ID is equal to, and let's get the object ID for our feature. Castown Gates, it is 52. Now we'll jump down to our for loop for row in cursor. We'll set row 1 to equal our X value. We actually don't need the OID at for this one. Let's just remove it just for clarity. And we'll set our row to 0. I know I'm kind of faffing around there, but I just want to show you the many different ways to use these cursors. We now call our cursor.updateRow and supply in our row, and we will run the code. Now keep an eye on this point here. When we refresh, it should shift to the left. And there it has. Now, the people should be happy. You might see that my Python window has cleared. This is because my laptop just restarted. But I'm back to where we left off in the previous example. Let's do one more example. We'll set a variable called xy and set this to equal a tuple. Now let's find something to move. This ATM here will do. Grab that, and let's say we're going to move that to here. I'll click into the tuple and I'll just hover my mouse around there, and we'll take the coordinates from underneath the map. So 697.255.14, that's our X value, comma, now our Y value 733.039.27. Hit enter. Now we go for our update cursor with ArcPy.da.updateCursor and supply in established points of interest. Our field will be the shape at XY token. We are going to use the tuple to update the X and Y values for our point. Now our where clause, where object ID is equal to 3. And finish off with as cursor. Now our for loop for row in cursor. We'll set row 0, which is our shape at XY, to equal our XY tuple. Now we call our cursor.updateRow method and supply in our row. Let's run. Looks to be successful. We'll refresh the map and we should see our point appear in here somewhere. Oh, there it is. Beautiful. I'll just clear the selection for the next video. In this video, we saw the power of field tokens. The OID at token is very useful as it enables you to access the object ID for any file type. The object ID field could be named object ID, FID, or another name, but the OID at token will always access that object ID field. We saw how we could use the shape at X, and shape at XY tokens to update geometry for features. In this video, we will assess the optional explode to points parameter with the update cursor. When the explode to points is set to true, each individual vertex in a feature is presented as a row in our cursor. We are in our ArcPy Cursor's APRX. We have our Python window open. I'm going to close the established points of interest attribute table and the domains ArcPy Cursors window and leave open the established buildings attribute table. We'll dive straight in with an update cursor with ArcPy.ea.updateCursor, and we select our Cerberus buildings. And in order for the explode to points to work, we need to add in the shape at token to access the geometry. We'll set our explode to points parameter to equal true, and we'll finish off with as cursor with our colon and hit enter. We'll use our for loop for row in cursor. We will print row 0, which is our name attribute, and row 1, which is our geometry, our shape at token. So for each vertex in each polygon, we are going to get a row. Let's run the code. Okay, we did not update anything. We did not use the updateCursor updateRow method. We just printed out the information to screen. We can see that for each vertex in every geometry, it printed out a row. Let's do that again, but this time let's just pick one feature. We'll set a where clause to where name equals the duck. Put a comma after our where clause. A few videos back, we shifted the geometry of the duck, and this is it here. Let's run our code. And we can see we have 5 rows returned. The first is the starting point of the polygon, and the last is the last point of the polygon, and this will match the starting point because a polygon is a closed feature. Let's run that again, but this time we will put dot type after row 1. Row 1 represents a geometry object, and we're going to get the type of that geometry object. Run our code, and we can see that all 5 are points. You're probably wondering, when will I ever need to explode to points using the update cursor? And the truth is, probably never. But here's an example anyway. We'll create a variable called points, and we'll create a list. This list is going to represent the coordinates for the 4 corners of a new building. In the resources of this video, there's a text file with the code for this tutorial. I'm going to copy the coordinates from there to save me typing them all out. And I'll paste over the empty list. So here we have 5 coordinates. The first and the last are the same, and the first 4 represent 4 corners of a new building. We'll hit enter. Oops, I missed copying a closing bracket. Let's go back to our last update cursor, and let's enumerate the for loop for index row in enumerate our cursor. Let's just print that index to screen for now, and we'll run. So we can see we have an index of 0, 1, 2, 3, 4. So as we know, the duck building geometry has 5 points, and we have 5 points in our list. How convenient. This is index 0, 1, 2, 3, and 4, which matches the indexes that we printed out. We're going to use the index to move the polygon that represents the duck. We'll set row 1, which is our geometry, which is now a point because we've exploded to points. Set that to equal our points list at the same index. And then we call cursor dot update row and supply in our row. This is currently the duck building here. I'll run the code. Now watch when I refresh. We can see that the building moved. So we moved each vertex individually. Again, I'm not sure there is much use for that, but it might be useful for you to know. In this video, we use the optional explode to points parameter with the update cursor. When set to true, the explode to points will return a row for every vertex in the geometry. In our last example, we saw that we could update each vertex individually. In this video, we will assess the use of the optional SQL parameter with the updateCursor. We're going to run through the available SQL clause capabilities with the updateCursor, but in all honesty, I feel like it is a copy and paste job from the SearchCursor. Not in terms of my videos, but in terms of the code base for this function. I don't see any reason why you'd ever use the SQL clause for an updateCursor. I'm not even sure how it would work if you did want to update data after using the SQL clause. Let's run through it so you know what I mean. We are in our ArcPy Cursors APRX. You don't have to have completed any of the tasks in the previous videos to follow through with this tutorial. I have the Python window open and the Selbridge Buildings attribute table. According to the documentation, the SQL clause is a pair of SQL prefix and postfix clauses. We place the prefix and the postfix into a tuple. The prefix can be none, distinct, or top. Now, top only works in an enterprise geodatabase. The postfix can be none, order by, or group by. Let's take a look at the distinct prefix clause. If you remember back to the SearchCursor video regarding the SQL clause for that cursor, we saw that distinct returns unique values. So think about it. If it returns unique values, how can you update those using the updateCursor? Throw in our updateCursor with arcpy.da.updateCursor, and we'll select our Selbridge Buildings, and let's use distinct on our type field. And we want to set an SQL clause, not an SLQ, an SQL clause, where it equals a tuple. Our prefix is distinct type, so we want unique attributes returned for our type field, and we set the postfix as none. We'll finish off with as cursor, hit enter, and for row in cursor we will print row 0, which is our type field. Let's run the code. Now, we didn't even get unique values printed. We got every value printed from the type field. Let's try again. Let's add in the rating field along with the type. And our SQL clause, distinct type and rating. And let's put in a count for the number of records returned. And we'll use enumerate. And we will print the count after everything has iterated. And before I forget, we'll set the enumerator to start at 1. Oh, I'm also forgetting to add in row 1 here. Very forgetful in this video. We'll run. And we can see that there were no unique printed. It just printed out every record. Let's do similar for the group by postfix. We'll remove our distinct and set this to equal none. And for our postfix, we'll have group by type. We'll remove the rating for now. And we will print row 0, which is our type. Let's keep the count in there. Let's run. We can see it failed. I'm not sure there's any way to use the group by postfix with the updateCursor. You might think, oh, it's because you have type wrapped in the list brackets. I assure you that is not it. Look, if you get it to work with the group by, send me a message and let me know how. But even if it did work, I don't see any way that you could use the updateCursor updateRow method to update the row based on groups. Now here's one that might work, the order by. Let's take that for a spin. We will order by, let's order by name and add the name into our list. Let's first print out row 0 and row 1, which are our name and type attributes, and print out the count. We won't try and update anything just yet. We can see they were printed out in order. That's nice. Let's try again. This time we will add in our rating field. And let's remove type. It's not required. We'll remove our print statement for printing out our attributes. And we'll set row 1 to equal 0. We're going to set every row for the rating to be 0. And we will call our cursor dot updateRow method and supply in our row. Okay, so we're going to update every attribute for the rating to 0. Let's run our code. We refresh our table and that has worked. So the order by seems to be the only SQL clause that really has any relevance to the update cursor. I'm not even sure what the relevance is. All you're doing is sorting your data and then updating it. So it seems like kind of an unnecessary step. But you may want to take that ordered data and add them or append them to another feature class. In this video, we assessed the use of the SQL clause with the update cursor, and we saw that for the most part, it was a head scratcher. The only SQL clause that seemed to perform as it should was the order by postfix clause. In this video, we will assess the use of the optional explicit parameter with the update cursor. The explicit parameter enables you to override default values for a field and allow you to insert null instead. We are in our ArcPy APRX, and you do not have to have followed along with any of the previous videos in this section in order to be able to follow along with this tutorial. We have our Python window open and our Selbridge Buildings attribute table. The rating field in our Selbridge Buildings has a default of 0, so when you add a new record, 0 is automatically populated for this field. We also see that nulls are allowed. We are going to use the optional explicit parameter with our update cursor to update the rating to a null value and to override the default of 0. Let's go down to our Python window. With ArcPy.da.updateCursor, select our Selbridge Buildings. We're interested in our rating field, and we're going to set explicit to equal true. We finish off with as cursor and enter. For each row in our cursor, we will set row 0, which is our rating field, to equal none, which represents null. We'll then call the cursor.updateRow method and supply in our row. We'll run our code. We can see our rating is still 0. Let's refresh the table. And we can see they've all been set to null and the default of 0 has been overridden. Let's go again with another update cursor. This time we will use the recommend field. We'll remove our explicit parameter for now. We'll set a where clause of name equals the mill. And we're going to update row 0, which is our recommend, to be null. We'll run that. We can see here that the mill has a recommend of yes. If we refresh, we can see it is now null. And we can see that rating also stayed at null. I'll clear the selection. We'll perform another update cursor. We'll add rating back in. We'll also add back in our explicit equals true. And we'll set row 1, which is our recommend, to equal 1. Let's run. Okay, we have the mill here. Rating is null and recommend is null. Let's refresh. And we can see that rating remained null and recommend updated to yes. Now this is important. We did not update anything in the rating. Let's take a look at the next example after I clear the selection. This time we're going to remove the explicit and we'll set row 1, which is our recommend, to equal 2. Now we're still not updating our rating, but because we are updating the row and it forms part of the row, we are going to see a change. Let's run. Here's the mill with rating of null, which we are not touching, and recommend, which we're going to update to no. We'll refresh. We can see even though we didn't update rating, we did not set explicit to true, meaning that rating was set back to default. Now you won't find this anywhere in the documentation, but you've seen it with your own eyes. One last thing to note about explicit. Instead of setting it to true for every field, you can pick and choose with a list of booleans. So rating is the first in our list. We'll add in true, and then we'll add false for recommend. The explicit list must match the length of the field list. We'll set row 0 to equal none, and we'll set row 1 to equal 4. So we're setting our rating to be null and our recommend to be 4, which is to be decided. I'll clear the selection first, and I'm going to remove the where clause. Let's do it for every record. Now we run. Take a look at our mill, which we've been manipulating. Rating is 0 and recommend is no. We'll refresh. We have rating set to null for everything and recommend to be decided for all our records too. In this video, we had a good assessment of how the explicit parameter works with the update cursor. When setting explicit to true, it allows you to override default values and apply a null value instead for a field attribute. In this video, we will see the optional spatial filter parameter with the update cursor in action. The spatial filter parameter is new as of ArcGIS Pro 3.2. Along with the new spatial filter parameter, there is the optional spatial relationship parameter. When you set a spatial filter, the spatial relationship automatically sets to a default of intersects. We are in the ArcPy Cursor's APRX, and while it is not essential that you followed any videos in this section up to this point, the knowledge build-up would be beneficial. You can follow along and treat this as a standalone tutorial. Just note that rating and recommend attributes in our Selbridge buildings will look different if you haven't performed tasks previous to this video. We have our Python window open and the Selbridge buildings attribute table. I'll drag this down a bit and make more room for the map and zoom out. Our polygons here represent land use. Over on the left, we have the Selbridge land use layer. We can right click and open the attribute table. We have 5 features here representing different land use classes. We have commercial, forest, industrial, residential and retail. These are represented in the map by the colours that we see over in the legend. Just to note that these are multi-part polygons. Look what happens when I click on residential. We have multiple polygons selected. The spatial filter parameter only accepts a geometry object. Let's take a look. I'll clear the selection. We're going to use a SearchCursor with ArcPy.da.SearchCursor, and we'll supply in our Selbridge land use. And we're only interested in the shape at token. We want to get the geometry for our residential lands. we'll use a where clause, f class equals residential. And we'll finish off with as cursor. For each row in our cursor, which we know there's going to only be one, and this is the feature that represents our residential polygon, we will create a variable called filter geom, and we'll set this equal to row 0. Row 0 is our shape at token. It'll return a geometry object. Let's run our code. Now when we print filter geom to screen, we can see we have a polygon object. Let's use the spatial filter with the UpdateCursor. With ArcPy.da.updateCursor, we supply in our Savage buildings this time, and we want to return the name and type field. I'll click into the Savage buildings attribute table. We'll set a spatial filter, and we'll set this equal to our filter geometry. And although we don't have to set the spatial relationship, as it'll automatically default to intersects, let's put it in anyway to be explicit. We'll finish our line of code with as cursor and hit enter. And for row in cursor, let's print row 0, which is our name, and row 1, which is our type. Let's just run that without applying the updateCursor updateRow method. We can see that 4 rows were returned for our Riverview apartments. Let's check those out in our attribute table. I'll sort by name by double clicking on the name field, and here we have our 4 apartments. And if we zoom in on the map, we can see that they intersect the blue polygon that represents residential land use. I'll clear the selection. I'll hit up. We'll change our name field to rating and the type to recommend. We'll remove our print statement, and let's set row 0, which is our rating, to equal 0, and row 1, which is our recommendation, to equal none, which is null. We then call cursor.updateRow and supply in our row. So for all 4 of our apartments, we are going to update the rating to 0 and recommend to null. And we are doing this by applying a spatial filter where our UpdateCursor is only returning salvage buildings that intersect the residential land use. We'll run our code. I'll select our 4 apartments and refresh the table. And we can see that the rating has been updated to 0 and recommend to null. I'll clear the selection. Let's create a variable called OID list and set this to be an empty list. Let's go back to our previous UpdateCursor and we'll add in OID at to access the object ID value for our records. And let's use the optional explicit parameter and set this to true. We saw the explicit parameter in the previous video. The explicit parameter will allow us to update a field that has a default value but can contain nulls and assign a null value for that field. We will set row 1 to equal none. Row 1 is now our rating. We had just set it to a value of 0. We are now going to reset it to null. And we'll set row 2, which is now a recommend field, to equal 4, which is to be decided. With each iteration, we are going to append to our OID list. And we want to append row 0, which is our OID at token. So we are adding the object ID to the list with each iteration. We then call a cursor.updateRow and supply in our row, which will update each row. Let's run the code. Let's do something with that OID list. Let's get an ArcGIS project object that represents our open APRX. So we set a variable called APRX to equal arcpy.mp.arcgis project, and we supply in the current string as a parameter. Not current, just current. We now want to access our cursor's map. We'll create a variable called m to stand for map, and we'll access the map through our ArcGIS project object, where we use the list maps function, and we supply in the name cursors_map. List maps always returns a list, and we're only interested in the first map object returned. We can print m. We can see it as a map object. m.name. We have the correct map. From our map object, let's get a layer object for our Selbridge buildings. We'll call this buildings_layer and set it equal to the map object dot list layers function, where we supply in our Selbridge buildings layer name. List layers always returns a list, and we're only interested in the first element of that list, which will be a layer object. Oh, because I forgot the S. Now we'll go again. Now if we print buildings layer to screen, we can see it is a layer object, and we can do building layers.name to see that we got the correct layer. We'll just print our OID list to screen. We can see we have 4 object IDs. We're going to call our layer objects dot set selection set function and supply in our OID list. If we take a look at the attribute table and the map, our Riverview apartments are not selected. When we run this code, the selection has been applied. We can rerun and remove the OID list and supply in no parameters to the set selection set function and hit enter, and the selection has been cleared. In this video, we saw the optional spatial filter parameter with the updateCursor in action. We saw that the spatial filter must be a geometry object. When the spatial filter is set, a default spatial relationship of intersects is automatically applied. For more spatial relationship types, I recommend checking out the Esri documentation. In this short video, we will take a look at the one property that is available with an UpdateCursor, and that is the Fields property. We are in our ArcPy APRX. You do not have to have followed along any videos in this section up to this point. This can be treated as a standalone tutorial. Let's dive straight in and take a look at the Fields property for the UpdateCursor. Let's create a cursor with arcpy.da.updateCursor. Supply in our Selbridge buildings. We'll accept the star for all fields, and we'll finish off with as cursor. We will now print our cursor, which is an UpdateCursor.fields property, and run. And we can see all our field names printed to screen inside a tuple from object ID to shape area. And this matches the fields in our Selbridge buildings attribute table: object ID, shape, name, type, rating, recommend, shape length, and shape area. You can also supply in a subset. Let's remove the asterisks and we'll put in name and type fields. And let's rerun. And we can see we got the subset of field names used. Having access to the field names used in a cursor can be very useful for debugging, and also if you want to print out reports, such as using as headings in CSV reports. In this short video, we saw how we could access the fields property for an UpdateCursor and get a list of the field names used in the cursor as a tuple. We have been using the UpdateCursor updateRow method throughout this section. Let's take a closer look at the method in this video. We are in our ArcPy APRX. While you do not have to have followed any of the previous videos up until this point in this section, it would be beneficial. This video can be treated as a standalone tutorial. Just note, if you are jumping in from another point, that the rating and recommend attributes in the Selbridge Buildings attribute table are more than likely different than what you have. I have the Python window open and the Selbridge Buildings attribute table. I'll close this land use, it's not needed. Let's start with an update cursor with ArcPy.da.updateCursor. We'll select our Selbridge Buildings and we'll supply in a list of field names. We'll go with name, type, and rating. We'll use a where clause where type is equal to commercial. We'll finish off with as cursor and hit enter. We'll iterate through our cursor for row in cursor. Okay, so the updateRow method takes a tuple. And just to show that the row itself is a tuple, we'll print the row. We'll run that code. And you can see it's made a fool out of me that it is actually a list. Either way, it is an iterable sequence. Let's press up and get back our update cursor. Let's create a variable called new row and we'll set this to equal a list. It can be a tuple or a list. And in our list, we'll have row 0, which is our name, and row 1, which is our type. Let's call the cursor.updateRow method and supply in our new row. Our new row has 2 entries, while our field names has 3. So we're expecting an error here because the updateRow parameter needs to have the same length, the same amount of entries as the field names. Let's run and see. And we can see we get a type error and we get a nice description: field size must match size of the row. So let's go again. We'll add in 5. We're going to update all the ratings for our commercial buildings to 5. Let's run. And we can refresh our table. And we see all the commercial entries have been updated with a rating of 5. Throughout this video, we have been updating attributes individually, like in this next example, where we set row 2, which is our rating, to equal 4. And then we've been calling the cursor.updateRow method and supplying in our row. And this has worked perfectly because, as we saw, the row is a row containing the attributes for the field supplied. So the length will always match. Let's run this code. We can see that it works. Refresh the table and our commercial now have a rating of 4. Unlike the InsertCursor with the InsertRow method, the updateRow method does not return anything. Well, I believe a function always returns something, so it will return a none value. Let's check that out. Let's update our ratings to 3 for all our commercial buildings. And let's print the cursor.updateRow to screen. We'll run. And we can see that for each iteration, none was printed out. The InsertCursor returns the OID. The updateRow for the update cursor returns none. Refresh our table and we can see that our rating has been updated to 3. In this video, we took a closer look at the updateCursor updateRow method. We now know that the method can take a tuple or a list, but the length of the tuple or list must match the length of the field names supplied to the updateCursor. Unlike the InsertCursor InsertRow method, the updateCursor updateRow method does not return a value, it simply returns none, which you could consider a value, but a pretty useless value. In this video, we will take a look at the deleteRow method that is available with the updateCursor. And as you might have guessed, the deleteRow will allow you to delete a row from your feature class. We are in the ArcPy Cursor's APRX. You do not have to have followed any video up until this point in this section in order to be able to follow this tutorial. In the previous section with the InsertCursor, we inserted Beaufield Veterinary Centre twice. The first time we inserted the Beaufield Veterinary Centre, it showed up in the incorrect place because we did not apply a spatial reference and a datum transformation. And this is our first entry of Beaufield Veterinary Centre here. We can see it highlighted in the map. Let's delete this from our dataset. I'll clear the selection. I have the Python window open, and as you've seen, the Celebrate Buildings attribute table. We'll use an UpdateCursor with ArcPy.da.updateCursor, and we'll supply in our Celebrate Buildings. We'll return all fields, and let's use a where clause where object ID is equal to 27. We can see that our feature has an object ID of 27. We'll finish off with as cursor, and for each row in our cursor, which there's going to be one, we'll call the cursor dot delete row method. Now there's no documentation for this delete row method. You can go check for yourself. It doesn't say if it takes a parameter or not. It doesn't say whether it returns anything. But I'm here to tell you it does not take any parameters. It is going to delete the row in the iteration. And let's put a print statement in front of it just to see that it does not return anything. Let's run the code. We got none. Let's refresh our map. And we can see that our building has disappeared. It has also been removed from the attribute table. Let's sort object ID by double clicking. Scroll down. We see that 27 has been deleted. Always be very careful when deleting data. When using the delete row, make sure you are deleting the correct data. I always recommend to test before you delete. For example, we could set this to object ID 28 and just print out row 0, which is the object ID, to make sure we have the correct feature, and then go back and delete the row. Cursor.delete row. I won't run this, but you get the idea. Just be very careful when deleting data, especially in a production environment. In this short video, we saw the UpdateCursor delete row method in action. When you call the delete row method, it deletes that specific row from the dataset. In this video, we will take a look at the reset method available with the UpdateCursor. We're in the ArcPy Cursor's APRX. While you do not have to have ran any of the previous video tasks up until this point to follow along with this tutorial, it will be beneficial for knowledge gain. We'll dive straight in with ArcPy.da.updateCursor, and we'll supply in our Celebrate Buildings. We'll retrieve two fields, our type and our rating. We'll finish off with as cursor. So we're iterating through every record in our Celebrate Buildings attribute table. For each row or feature, so for row in cursor, we'll state if row 0, which is our type, is equal to retail, not retail, we will set our rating to equal 5. I know, it's a blanket rating. It's just to show you the reset method in action. Let's print row 0 and row 1 to screen, and then call the cursor.updateRow method and supply in our row. We'll then step out of the for loop and we will print resetting cursor. We'll then call the cursor.reset method, and we will go for another for loop for row in cursor if row 0 is equal to commercial this time. Let's set our rating to equal 4. We'll print row 0 and row 1, our type and rating to screen, and we will use the cursor dot update row method and supply in our row. Now before I run this, let's just recap. We are using an update cursor and our fields are type and rating. For each row, if we hit a type of retail, we're going to update the rating to 5. We'll print our updated row to screen before applying the actual update using the updateRow method. This part here will iterate through all records, and then when you hit the cursor.reset, it is going to reset the cursor back to the first record. We then run through all records again. This time, if the type is commercial, we set the rating to 4 and we print our new row to screen before updating using the updateRow method. I'll just expand this attribute table here and we will run. And let's take a look at the printout. So we went through every record first and we found where it was retail and we set to 5. We then reset the cursor and we went back through all our records and found our commercial records and printed those to screen. I'll refresh the table. We can see all our retail are 5 and all our commercial have a rating of 4. Just to implant what is actually happening, let's use OIDs. So we don't have to go through a lot of this. Let's put the OID as the last in the list. OID at. We will print row 2 and print row 2. And let's rerun. So we can see it has iterated down through our object IDs and then reset back to 1 and gone through all our object IDs once more. In this video, we saw the updateCursor reset method in action. When the reset method is called, it sets the cursor back to the first row in that cursor. In this video, we will see the updateCursor in a slightly different light. Instead of using the with statement, we will assign the cursor to a variable where we can then use the inbuilt Python next function to move through each row in the cursor. We are in our ArcPy Cursor's APRX, and while you do not have to have completed any of the tasks from previous videos up until this point to follow this tutorial, the knowledge gained would be beneficial. I have the Python window open and the celebrated buildings attribute table. If you are jumping in fresh at this point, just note that your rating and recommend attributes will be different than what you see here, but that's okay. Let's create a variable called cursor. And let's set this to equal arcpy.da.updateCursor. Let's apply in our Celebrity Buildings as our in table. And we will set a list of fields to be name and rating. We'll run this line of code. If we print our cursor to screen, we can see it is an updateCursor object. Python has an inbuilt function called next. And if we supply in our cursor and hit enter, we can see it has returned the first row of our cursor. We can see it matches the name and the type for object ID of 1. I'll clear that selection. We can go again, and now we're moved on to the second row and the third row. We saw in the last video that you could call the reset method on an update cursor to reset it back to the first row. So let's call our cursor.reset method and run. And let's call the next method again. And we're back to our first row. Can we update each record individually? You betcha. Let's reinstantiate our cursor variable. If I call cursor.updateRow, and let's apply in a list. We'll pretend we're going to update the name to Glenn's house and give it a rating of 5, obviously. And watch how happens when we hit enter. The iteration has not started. Let's create a variable called row, and we'll set this equal to next cursor and hit enter. We'll print the row to screen. We have our St. Patrick's with a rating of none. Let's set the second element of our row to equal 5 and hit enter. We'll print row again. We see we have St. Patrick's with a rating of 5. Now let's call our cursor.updateRow and supply in our row and hit enter. Here we have St. Patrick's with a rating of null. If we refresh the table, we can see it now has a rating of 5. I'll clear that selection. We can call next cursor, and let's call it again to skip over the Abbey Lodge. And now we have the Celbridge Library. So if we take a look at our attribute table, we know that the Celbridge Snooker Club is next. Let's set our row to equal next cursor. Hit enter, print our row. We'll update our rating to be 3. We'll downgrade and we'll call cursor.updateRow and supply in our row. Hit enter. And if I highlight Celbridge Snooker Club, we should see the rating of 4 downgrade to 3. The table has been refreshed and we can see it is now a rating of 3. I'll clear the selection. And to remove access to our cursor, let's use the delete command in Python and our cursor and hit enter. Now if we type cursor and hit enter, the name cursor is not defined. We do not have a variable called cursor. In this video, we saw how we could use the inbuilt Python next method to move through the rows in our cursor one by one. We also applied the reset method to reset our cursor back to the first row, where we could then apply the next method all over again.